So today, when we finish this lesson, you must be able to describe the properties of a gas. You must be able to describe the properties of a gas. Secondly, you must be able to explain the movement and arrangement of molecules in gas. As you know from last time, my name is Mr. Ben Udiani. I am going to give you a very interesting lesson, and then I hope you are going to enjoy it. Those were my two objectives for the lesson. Now let me start with the lesson. Firstly, what you must know is that last time when we learned about phases of matter, we learned that we have got a solid, a liquid, and a gas. So we also learned that gas molecules are far apart. All the gas molecules are far apart, meaning they are not close to each other. Then let's move to the next slide. Yeah, is the properties of a gas. Properties of a gas are as follows. Number one, there are few molecules in gas that they are invisible to us. The molecules are very few, so you cannot see them. In other phases of matter, you can see them because they are close. They make close contact. Now, secondly is that even though they are invisible, we know they are there. You cannot just say there is no gas. There is gas, always there is gas, all over there is gas. Even if I can take a container, scientifically, there is a gas inside. But people on the street, maybe they think there is nothing. You ask somebody what is in the glass, will say there's nothing. But we know that there is gas. The thing is that we cannot see it because it is invisible. A gas will not stay in an open space. Like here, it won't stay. The gas needs to be put in some container for it to be kept in one place. We've got different types of gases on air, which we don't see. To keep it, you need a container. So a container like this one, this canister, can keep the gas inside. Even the container like this one, it also have gas inside. You can also blow the balloon to make the air, to keep the air in the balloon. That is the only thing you can do to keep the air in the balloon. The next one is that gases on air can be compressed to take less space. It means if you want more gas to be kept, you need a space where you must put it. Large amount of gas can be put in a very small space. Like you can compress it and put it on number 5. Gas resists being compressed, so it needs great force. So even if you compress it, it needs force to be compressed. Like a bicycle pump, you need to push it in order for you to take the gas into the tire of the wheel. Those are my properties of a gas that I've planned out for you. What you need to know is that gases are invisible to people. Their molecules are so far apart that we cannot see them. Can you identify one gas used daily? The air around us is made out of many gases. It's made out of many gases. You cannot identify it. Thank you. Thank you from Thomas from Tevaso. Yes, gases are made out of, air that we have is made out of many gases. The first important gas is oxygen, the one that we need in order for us to live. We need oxygen. Secondly, we need nitrogen to make different chemicals. We also need hydrogen. So carbon dioxide is the gas that we take out from our mouth or our lungs. Those are the gases that basically I can tell you about today. But there are many other gases which are pollutants. These gases, they make our air dirty. So we need to get rid of them. So many people burn different things in different places. So they make the atmosphere to be filled with very bad gas, which causes what we call global warming. We don't need that type of damage because the earth is important to us. The last one, gas will not stay in open container, but it will spread outwards. Now it is your turn for you to answer my questions. Question number 1, can you store gas in an open container? I'd like the answer from one of you. Can you store gases in an open container? They must say yes. Everybody say yes. No, you cannot store gas in an open container. Yeah, Pushia, you are right. Yes, Homo. Yes, you are right. Okay, thank you. You cannot store gas in an open container. You need to close it up in order for it. As you can see, this container is closed and gas is compressed inside. Now, secondly, why can't you see gas? Can you answer that question? Why can't you see the gas? There must be a reason why you can't see it, but you can see the other things. You can see solids, you can see liquids. Thank you. From Winnie, it is invisible. It is invisible. Thank you, Thomas. It is invisible. Yes, its molecules are very, very far apart. Thank you. You cannot see it. Yes, you cannot see it. Yes. Now I'm getting next to the next slide. Yes, take away message. Number 1, we can contain gases like in a balloon, like this one. You can contain gas here. Once you punch it, then the gas disappears. You can keep the gas inside here. Now, secondly, I've shown you the canister. The bubble can also keep the gas. Now, number 2, you cannot see, you cannot feel, you cannot smell some gases. But other gases, they are very stinky. Other gases are very nice. You cannot even smell them. Number 3, we can only see the containers that hold the gases, but we don't see the gases. Number 4, air is made out of different gases: oxygen, carbon dioxide, vapor, nitrogen, hydrogen, and many other gases. Number 5, the ozone layer, which is covering the earth. On the side, on the earth, we've got the air around the earth, and then right up there, we've got something called ozone layer, and this ozone layer helps us to be safe from different dangerous rays from the sun. So that is called the ozone layer. It's made out of a layer of gas. It protects the whole world. Number 6, some gases are poisonous. You know, some gases like chlorine. Chlorine is very poisonous gas. People were using it during the First World War in different countries, especially in Europe. Very, very dangerous. And it can kill the germs. The other dangerous gas is sulfur dioxide. Sulfur dioxide is the one which is produced in the chemist, making different products, like plastic products. They use too much plastic material. They burn it, then it takes out what you call sulfur dioxide. The sulfur dioxide is extremely dangerous. It can make sulfuric acid. You know, sulfuric acid is very, very dangerous. It's a battery acid. So it's very dangerous to people and animals. Number 7, to live, people need oxygen. We need oxygen. We breathe in oxygen. We take out what? Carbon dioxide. That is why we are alive, is because we need oxygen and then we take out carbon dioxide. So plants need carbon dioxide. Plants need carbon dioxide to make energy. So air is very important. Now, here is the activity I'm giving to you. Number 1, can you name one gas that humans need to survive? Can you name one gas that humans need to survive? Oxygen, thank you. Thank you. They need air. Oxygen, oxygen, thank you, everybody. Willie, Kelvin, yes, we need oxygen. Diane Banjwa, we need oxygen. Yes, Kaki, Kaviso Buntle, we need oxygen. Thank you very much for your answers. Thank you very much for the answer. Number 2, can you name one gas that plants take in? The plants need that gas. Plants need that gas. They take in that gas, those plants. I mentioned 2 gases. I said humans need, or animals need oxygen. Okay, thank you, Kevin. They need carbon dioxide. They need carbon dioxide. Everybody is correct. Thank you. The next question, can gases be stored in an open container? Like I take the dust like this. No, it can't be kept. Yes, thank you for the answer. Dylan, Laviso, yes. Oma, yeah, Joanna, Victoria, to me, yes. Everybody, Moses, Colin, Kidi, yes. Rodisang, you are very right. Now, next one is that, can gases be compressed? Is the next question, number 4. Can gas? Yes, it can be compressed. Yes, everybody knows the answer. I like it that you understand. You'll be very clever people. Now, the next question, where in the car is gas needed? Where in the car? Inside the car. Where do we need the gas in the car? In the tire. Good. Carol, you are very clever. Carol, in the tire, good. In the tire, even in the engine. Tebaso, you are an engineer already. Oh, Tebaso, you are an engineer. Very brilliant. Also, the engine needs the oxygen. Thank you. Now, number 6, how are the molecules in gas arranged? We remember we said in solids, they are tightly packed. In liquid, they are close together. What about gas? What about gas? Far apart. Thank you, Carol. Thank you, Kaki. Yes, thank you, Kevin. Thank you, everyone. Oh, gross. Thank you, they are apart. We can't see them. That's why they are far apart. They are not close. Then the next question is that, what happens to a gas when you compress it into a container? What happened to it? What happened to a gas if you want to compress it into a container? Yes, it can stay in. It fills up the whole container. Yes, somebody say it explodes. Joanna, yes, it can even explode. It can even explode. It can be kept in a container. If it's too much, it can stay in. Thank you. Yes, very clever. I take all your answers. I believe that you are all correct. Next one. Now I'm going to do an activity to you. The first activity is that I'm going to make carbon dioxide. Okay, how do you make carbon dioxide? Now, let me show you what do I need. I need what you call a vinegar. Here is a vinegar. Then I also need what you call a cook soda. You know the cook soda. Cook soda, you know, you use at home. Cook. You need those 2 things. Now I have poured the vinegar inside this bottle. Then I'm going to pour the cook soda in this balloon, bicarbonate of soda. Thank you, Carol, you are very clever. Then I'm going to pour this bicarbonate soda inside this. Then I'm going to put it on the lid of this bottle. Let's see what is going to happen. Let me try to put it quickly. Okay, yes, it is there. It is in. Here is the balloon. is flat. You see the balloon is flat, and here is the bicarbonate. There is the vinegar. Then I immerse it like this. You see what happens? You see what happens? What did I just make? Inside there is what we call carbon dioxide. Yeah, there is carbon dioxide because when the vinegar it mixes with this cook soda, bicarbonate of soda, it produces what we call carbon dioxide. Then I'm going to put it aside. I'm going to put it aside. I finish with this one. Then I get to the next experiment. Now I want to store the gas in the balloon. I'm going to take another balloon or even that balloon and try to store the gas inside that balloon. Then here is the balloon. Let me use that balloon. Here is the balloon. Here is the balloon. Now, I've already stored the air in the balloon. Can I use the needle to blow this balloon? What will happen if I put the needle here? What is going to happen when I put the needle here? It will pop. Okay, let's see. I have a needle here. Here is my needle. Do you see my needle? Here is my needle. Then I'm going to put it here. Let's see if it pops. What happens? Did it pop? What happened? What happened to this balloon? Okay, it won't pop. Let me see. I'm going to try this thing to see if this thing can pop the balloon. You know what it is? Yes, if you spill it on top, then it will pop this balloon. But the needle, you put it this side, it won't pop the balloon. This is the lemon. It can, if you spray it, sprinkle it on top, it's going to pop it. But for now, this one is dry. I can't make it pop it. Thank you very much. So gas can be stored in a balloon. Eh? Now, the other thing is that gas can make a pneumatic machine. For instance, the truck. When the truck starts, then it needs the air. It needs to fill up the air tanks. Then it takes the air from the atmosphere and it fills the tanks so that the brakes can work. Now, yesterday, you remember what I did? This thing contained only air inside. There is air here, only air. There's nothing else. There is air. This is a syringe. It's air inside. Then I've just made this thing looks like a jaws of life. Then I put it here. I put it here. I just put it here. You see what happens. Then I press this side. I press this side. You see what happens. You see what happens? It goes up, ne? It opens. This is a pneumatic machine. We call it, I can take it back. It's a pneumatic machine, but we made this pneumatic to work for us. We made this pneumatic. It's a pneumatic machine. It uses air. There is air inside this tube that makes this thing to go up. So when people are involved in an accident, they use the pneumatic instrument to rip the car apart so that people can be taken out of the car. So this is a pneumatic example of a pneumatic machine. You see, again, simple. This is a pneumatic tool. Lastly, I'm going to show you aerodynamics. It uses air as well, aerodynamics. Now I'm going to take the candle. You see the candle? I put the candle here. Now I'm going to put this box here to block the candle. Here is the bottle, the candle, here is the box. Yes, now I'm going to blow here. What is going to happen when I blow this side? Can anybody tell me what will happen to the candle if I blow it this side? Okay, nobody knows. Now let me show you. Yes, let me show you. What is going to happen? Yes, okay, so we really say nothing, but let me show you. I'm going to start blowing. Let me start blowing. Let me blow. Why is the candle not out? Can you tell me why is the candle not out? Why is the candle not out? Why is the candle not out? Okay, now I'm going to remove it. Then I put the glass. Here is the glass. It's the same size with the this cupboard. The same size with the cupboard. Then I put it here. Now I put the glass. Here is the glass. I'm going to blow here. What is going to happen? Why did the candle go out? But did not go out with the box? It's because of what we call aerodynamic. Aerodynamic. The aerodynamic is used, example, in the cars. Do you see this car? Do you see this car? There is what we call drag. The air makes it not to go very fast in front here. Now, if you can change the shape of the car and do it like this, then the air can move like that easily. So the car, as it is moving on land, it is also moving in the air. It is not only moving on land. So the inventors realized that this air blocks the movement of the car. Even if you put the same engine, here, then this one will be faster. The one on top will be slower. This one will be faster because of aerodynamics. So that is air. Now I'm going to put the candle again on. I light it again. Now I'm going to pour water on the candle, not on top of the candle. I'm going to pour it. Yes, here is the water. Now I pour the water, okay? Now I'm going to put the glass on top. What is going to happen? What is going to happen when I put the glass on top here? Can anybody say kaki? Everybody, tevaso. It will blow. Okay, let's see what will happen. Look what is happening. Just look what is happening. What happened is that the water went up. The water just went up. It sucked the water because it used all the oxygen inside. So for this candle to blow, to keep on lighting, it needs oxygen. So because the oxygen inside was used up. When I put it, there was still oxygen. Then when I leave it for some few seconds, then the oxygen was used up by the flame. So for things to burn on earth, we need oxygen. Oxygen must be there for things to burn. Now let's go to the next slide. Okay, next time I'm going to teach you about changing the state of materials. But now, what I need from you, I have a test for you which you must do so that I can check whether you learned things that we have I taught you throughout the week. But let us revise again. Let us go back to our objectives. Let us go back to our objectives and see whether you do remember everything. Can you describe the properties of a gas? Can somebody describe a properties of a gas? Rorisang? Rorisang, can you describe properties of a gas? Okay. Yes, they take up the space of a container. Carol, you are right. Thank you. They take up the space of a container. Is correct. Molecules are so far apart. Kelvin, you are right. completely correct. They are far apart. Okay, they are invisible. Kelvin is very clever. You are going to be an engineer. Kelvin, okay, you can't see them because they are small. Thank you. You can't see them. Yeah, Apiwe, okay. Can you give me? They are invisible. Thank you. Oh, Colin say it's new, but you can just revise the book for NST grade 4. No, solids are very firm. We are not on solids. We are on what you call gases. They stay in a container. Thank you. To me, yes, they stay in a container. They are too small. Good. They can be compressed. Yes, like yeah. Others are dangerous. Good, like sulfur dioxide. Okay. Yeah, sometimes, you know, in the mines, people die because of the gases that they smell underground. Like they need to test every time in the mine if there is a dangerous gas which can kill the miners who are digging underground. So the scientists normally are always in the on site to check as whether there is dangerous gas which can kill the miners underground. So the other thing is that I told you about sulfur dioxide, the gas that destroys the ozone layer, which is causing what we call global warming. As you can see these days, there is a lot of rain. Sometimes the rainfall in winter, sometimes it comes with the storm. It's because of the sulfur dioxide that have damaged the ozone layer. The ice caps are melting out. People are drowning. That some land is being covered with water, which was previously not covered with water. Animals are losing their habitat. So that is what is happening. So air is important. Now I want to ask you another question. I want you to give me an answer. Are humans living on land or in the air? Listen to my question. You say humans are living on land. Okay, listen, I said on land and in the air. Now, let me ask you, if you can take a human to Mars planet, you say go and stay in Mars. You know that in Mars planet there is land. There is land in Mars, or in space there is land. There are asteroids there roaming around. Even there's the moon. I take you to the moon. Are you going to live in the moon? Okay, they will say no, you can't live in the moon. You can't live on the moon. My answer is simple. People are living on land and in the air because we are covered with air all over. When you get to the water, you need some air. You can't live in the water. You need some air in the water. So as we are living on land, we are walking on land, we are also moving in the air. So that is a scientific question that I was trying to challenge you so that I check whether you do understand science to the level that I require you to understand it. So now, people, I'm going to take this away. Now I've got a test. Do you see the test that I gave you? Or if people who don't see the test, I can just read it out. Maybe you can write, you can answer it while I am with you now. Now I have a test, question 1 of the test. Just listen carefully. Question 1. And somebody say they can't see. Question 1.1. Can you see it? Can you answer question 1.1? It's a multiple choice question. Okay. The question is, which of this statement is false? Which of the statement is false? The statement that is false, if I read out 4 statements, you tell me with the statement which is false. Number A, oxygen is a gas. Number B, gas can be stored in an open container. Number C, gases can be compressed. Number D, carbon dioxide is a gas. Which one is correct? Yes, number C is correct, ne? Okay, no, thank you for the screen, thank you for the screen, thank you for the screen. Oh, thank you, Mr. Khalid. Okay, thank you, Mr. Khalid, for that. I need to go to the test, that I gave them. Okay, it's almost nearly the last slide. Okay, thank you. There it is. Thank you very much. Question number 1.1. Who can answer question number 1.1? Jenna said B. Bunte say C. Dylan say B. Everybody say B. The correct answer is C. The correct answer is C. Now let's go to 1.2. 1.2. Molecules in a solid A, B, C, D. What is the correct answer? Number C. That's correct, Winnie. Thank you very much. We can go to the next one. We can go to the next one, Mr. Khalid. We can go to the next one, 1.3. Molecules in liquids. Oh, unfortunately, we can't see it. Okay. Molecules in liquids. You must finish up that one. Molecules in liquids. I have it here with me. It's just that this one is not in a presentation format. Unfortunately, you can't see it there, but I'll make sure that you get it. I'll make sure that you get it. Then 1.3, I'll just read it, then you just give the answer. 1.3 says, molecules in liquids. Number 1 is A, move randomly. Number B, vibrate only. Number C, move past each other. Number D, move very fast, far apart. Thank you, is number C. Thank you, everybody know it. Thank you very much, Winnie. Thank you, Carol. Thank you, Oma, Emily. Thank you, Rorisa. Okay, that's correct. You are very brilliant. Then, question 2. Here is question 2. Write true or false. Liquids are visible. Is it true or false? Liquids are visible. Okay, yeah, it's true. Liquids are visible. Everybody is right. Oh, thank you very much. I clap hands for you for doing well. Number 2.2, gases flow when poured on a surface. Gases flow when poured on a surface. When you pour gas on a surface, it flows. Does it flow? Tevaso, you are right. Tevaso is right. Gas does not flow on the surface. Gas, Rose, you are right. Victoria, you are right. Gas do not flow. It's false. They don't flow. They move randomly. You cannot pour it on a surface. You cannot take gas and take the gas and pour on a surface. It won't happen. Now, the 2.3, solids can be compressed. If I take a solid, I can compress it. True or false? Can I compress a solid? You can't compress it. It's a false. Then I'll move to the next question. I'll move to the next question. This one I'm going to pass because you can't see the molecules. I'll go to question 4. I'm going to ask you, is a sponge a solid or a liquid? A sponge. Yes, it's a solid. Thank you. Now, I want 2 reasons why you say a sponge is a solid. Scientific reasons. Why do you say a sponge is a solid? Give me 2 reasons that tell you, that tell us as scientists that a sponge is a solid. Yes, number one, you can see it, you can touch it. Yes, you can touch it. Yes, the molecules are tightly packed. You can touch it, you can see it. I want another reason. You can see it. I need a scientific reason. You can't put a finger through it. Very good, Kelvin. Kelvin, very good. Yeah, yeah. So yes, you can feel them. Good. That is why we say they are solid. Now, number 4.3. Why are gases invisible while solids and liquids are visible? Why are gases invisible while solids and liquids are visible? The molecules are far apart. From Winnie, thank you. The molecules are far apart. Gas is thin. Dylan, you're also right. Molecules are far apart, so you cannot even see them. You cannot see them with your eyes. You need this microscope in order for you to see the molecules of a gas. Now, the last question. I have the last question here. Let me come to the last question. Question number 4 is that, give me 2 examples of a solid. 2 examples of a solid. 2 examples of solids. Is a brick, Kelvin? It's a brick. Is a glass, Buntle? It's a can, it's a sponge, rock, many other things, bones, good, gate, window, metal, everything. Yes, thank you very much. Thank you. The next question, liquids. You are very clever. Give me 2 examples of liquids. Examples of liquids. Water, juice, yes. Soda, yes. Ink, yes. Tea, lot of things, milk, mercury. Very good. Oil. Thank you. Now, the last one, give me 2 examples of gases. 2 examples of gases. 2 examples of gases. Oxygen, good. The first important gas, nitrogen, carbon dioxide, air. Okay, yes, good. Even water can change to gas. It's true. You are right. Yes, hydrogen, good. Helium. Yes, Risang, you know helium. Good. You are very clever, Len. Nitrogen. Okay. Now, the air is composed of different gases. Different gases. This is another question. The air is composed of different gases. Now, tell me which 2 gases you know that are very dangerous to us. They cause what we call global warming. Chlorine, number 1. Even carbon dioxide, too much of carbon dioxide, gender burns, correct, you are right. Sulfur dioxide, very, very dangerous. 1. Yes, those gases are very dangerous, but carbon dioxide, for carbon dioxide is also important. It must not be too much, but it's also important for our plants. We need it for our plants. Let me sing for you another song today. Maybe I'll use the same tune for yesterday. It's about carbon dioxide. Don't think oxygen is the only gas that is important to us. Also carbon dioxide. Let me sing my song so that you keep my song. Yesterday I've sang the same tune. Now today I'm also singing the same tune, but I'm changing the wording. Yes, here is the song. There is the way that plants make food for the whole world. There is the way that plants make food, photosynthesis. There is the way that plants make food for the whole world. There is the way that plants make food, photosynthesis. They need water, carbon dioxide, sunlight, that's all they need. Water, carbon dioxide, sunlight, that's all. There is the way that plants make food for the whole world. There is the way that plants make food, photosynthesis. There is the way that plants make food for the whole world. There is the way that plants make food, photosynthesis. They need water, carbon dioxide, sunlight, that's all. Now, I wanted to tell you that also carbon dioxide is a gas. It is very important. The plants need it in order for us to make food for us. Thank you for joining me today. You have been interesting to me. I enjoyed this lesson. I'm inviting you again next week. Boom. It's going to be a lot of things that we are going to do, very nice experiments, so that you learn better, you enjoy the lessons, you can play with science, you can become doctors, engineers, and many other qualifications that you can achieve through science. Please do science. I want you to solve the problems that are facing the world. I want you to make change, and I love you. Keep well, and bye-bye, and stay healthy. Stay away from the streets. Stay away from the drugs. Stay away from the virus. Stay away from the everything, the germs, and stay with your parents at home. I love you all, and thank you. See you next time when we'll be doing very interesting topic, which is better that changes faces. Thank you very much. Bye-bye. Love you all.